Hallucinating Cities, a post-human urban design method based on neural style transfer. Matthias Del Campo, Sandra Manninger, and Alexandra Carlson, University of Michigan. First of all, a thank you to the organizers of the conference. We would also like to thank Taubman College and Michigan Robotics for their support, in particular Dean Jonathan Macy and Director of Robotics Jesse Grisel. Today I would like to present the paper Imaginary Maps. This paper presents a design approach that uses the internal representations of deep vision neural networks to generate and transfer stylistic form edits to both 2D urban maps and target landscapes, rural, urban, real, or imagined. The main aim of this paper is to demonstrate and interrogate a design technique based on deep learning. The discussion includes aspects of machine learning, 2D to 2D style transfer, and generative adversarial networks. The paper examines the meaning of agency in a world where decision-making processes are defined by human-machine collaborations and the relationships to aspects of a post-human design ecology. Taking cues from the language used by experts in AI, such as hallucinations, dreaming, style transfer, and vision, the paper strives to clarify the position and role of artificial intelligence in the discipline of urban design. The map. This icon of urban planning goes far beyond its mere meaning as an abstraction that allows to execute in a controlled manner the materialization of matter in space. It rather represents a vast collection of possible solutions for urban problems. Considering the gigantic amount of data that a collection of maps spanning more than 3 millennia represents, it appears almost evident to use this enormous repository of urban imagination in the age of big data. A quick search on Google yields 8,920,000,000 images tagged map. The enormous vault that the discipline of urban planning has generated throughout the ages forms the natural resource of our discipline, waiting to be mined and processed, not to copy or imitate existing urban design solutions, but to find bespoke solutions to specific problems. How do we deal with big data as an opportunity for architecture design? An example of retrieving data for databases. The code scrapes the internet for images with particular labels as a first step to create a database as source for any form of style transfer, dreaming, or hallucination. This is how we can tap into the existing resources of our own discipline in order to create novel outcomes. The second important aspect in this process is the training of the neural network. Vision, dreaming, and hallucination in architecture. It is quite fascinating how computer science has adopted the vocabulary of neuroscience to explicate the processes invoked in neural networks, and the proximity of this language to the wording of architecture when it comes to the imagination of the discipline. Terminology like vision and even dreaming and hallucinating made regular appearance in the manifest heavy postmodern era of the 1970s, such as in the written works of Hans Hollein, Hausrucker Co., and Co. Pimmelblau, for example, the Metaphor and Metamorphosis exhibition. And it was chronicled extensively in Günther Feuerstein's oeuvre. The terminology still provokes the spirit of particularly advanced architecture, albeit in a certain romantic and poetic fashion, which this paper is not about. In this paper, we lay the ground for a fascinating possibility, a computational method to train neural networks to learn and recognize a variety of urban features, styles, and aspects, and possible ways to get neural networks to generate novel planning solutions. Another possible application for this approach is the possibility to create an app that is able to analyze urban plans and check them for errors, for example, their accordance to code, their energy consumption, or their functionality. The approach, however, offers an entire set of possibilities that go beyond its application as a mere tool for optimization, thus provoking questions pertaining to the nature of creativity, agency, and post-human culture. In this technique, we utilize style artifacts that can be exaggerated to a point of hyperbole, transforming the natural balance of human style and design into a pareidotic and compositionally unstable but novel form, rooted in a post-human but humanly accessible architectural feature. An example for this approach was tested by the authors by creating a database of nolimaps of various cities scraped from the web and applying this style to various target images. In a playful approach, we chose images such as 19th century science plates of the moon, topolines of alpine areas, and random Asian cities as target files. The resulting images serve as a first proof of concept of a possible neural network technique for the design of cities. In the following, the authors would like to explain the technical background of this approach, explaining the computational methods used in neural networks.
First, we will talk about neural style transfer. The objective of this method is to map the texture of a style image onto the structure of a content image, and we show two examples of this on this slide. In the left example, a city map is generated by transferring the style of the moon landscape onto a Noli map of Washington, D.C. On the right side of the slide, we show an example where we have transferred the style of the same Washington, D.C. Noli map onto the surface of the moon. So, how do we use neural networks to do this? In the figure on the screen, we have a content image on the left, a style guide image on the right, and our output style transferred image in the middle. Each of these networks is the same trained classification convolutional neural network, identical to the one that we discussed previously. The neural style transfer process iteratively makes changes to the pixel values of the output image based upon two criteria. First, how similar the spatial structure of the output image is to the spatial structure of the content image, and second, how similar the texture of the output image is to the texture of the style image. For each of the content, style, and output images, we can use the trained network to project these images into the activation map feature representations shown in the blue and red maps on the screen. These activation map representations can be used to measure the similarities between the output image, the style image, and the content image. To preserve the structure of the content image, we can minimize the differences between the output image's activation maps and the content image's activation maps by iteratively changing the pixel values within the output image. This effectively transfers the spatial structure of the content image into the output image. To transfer the texture of the style image, we can minimize the difference between the statistics of the style image and output image activation map features, i.e., how these activation map features co-vary and co-occur with one another. And we do this by changing the output image pixels. So if we minimize the two criteria simultaneously, we can transfer texture from the style image while maintaining the global spatial structure of the content image.
Conclusion. In an outlook, it can be stated that this is only a first attempt in the area of the critical interrogation of planning and architecture in the age of AI. In fact, there is still a lot to be done. The first alien results achieved in this paper can only be seen as a first tapping into the potentialities of this approach. From tapping into novel design direction that rather talk about how machines see our world with its wonderfully strange results in terms of morphologies, chromatics, and possible theories to profoundly pragmatic approaches. It is feasible to speculate about the pragmatic applications of the findings in this paper, the possibility to create an application as a corrective tool in the planning process. Through data mining, it would be possible to create a neural network that can analyze plans to explore, for example, if they comply with local building codes, or the plans can be analyzed to confirm if they are functional at all. All of these abilities need to be trained, heavily relying on human judgment at the beginning, but after a period of training, increasing its abilities. Further research needs to be done to dive deeper into the opportunities presented in this paper. To this extent, the work on this problem can be considered a work in progress. The refinement of the algorithm allows to continue the conversation laid out in the conclusion of this paper. The authors of this paper have already started refining the approach and are looking forward to the in-depth interrogation of this posthuman design ecology.